Project, Sentiment Analysis with Text Mining. In this lesson, we will learn the basics of sentiment analysis using Python. We will explore real data, clean it, visualize it, and build powerful models. Sentiment analysis helps us detect whether a text feels positive, negative, or neutral. This technique is used in reviewing product feedback, analyzing social media, and more. Let us get started. Running the cell now. First, let me show you how we keep things neat in our notebook. We are telling Python to ignore warning messages so our output is cleaner. We are importing the warnings library. Import numpy as np. We set the random seed to 42 for reproducibility. We are turning off warnings for the whole notebook. Running the cell now. Here, we set up our environment by importing necessary libraries and suppressing warnings to keep the output clean. This preparatory step ensures that subsequent code runs smoothly and results are easier to interpret, laying the foundation for our sentiment analysis workflow. Practice: why might we want to hide warnings when working with real data? Dataset, Telecom Customer Churn. For our Capstone project, we will use the Telecom Customer Churn dataset. It contains customer subscription info and comments, which we can analyze for sentiment. This real-world data is popular in business intelligence. Running the cell now. Let us load the data so we can peek into it right away. We add a comment that describes what this cell is for. We import pandas to make data handling easy. We get the data directly from a GitHub link, so anyone can reuse this step. We read the dataset into a variable called df, which stands for data frame. We print out the shape, showing the dataset size. We display the first 3 rows to understand what type of info it contains. Running the cell now. This output confirms we successfully loaded the Telecom Customer Churn dataset, which contains 7,043 rows and 21 columns capturing customer details and service info. Notably, key columns like churn, tenure, and monthly charges hint at important factors affecting customer retention. This initial data overview sets the stage for exploring patterns and building predictive models in our churn analysis. Try it. Can you find a column with customer comments or feedback? Step 1. Exploring the data. Before we analyze sentiments, we should understand what kinds of columns and values our dataset has. Let us do a first exploration of the dataset's columns and data. Running the cell now. It is useful to check what features and fields we have. We print out all the column names so we know what features we can use. We print the list of column names in the dataset. We add a blank line for clarity. We print all the values for the very first row as a sample. Running the cell now. This output shows us the full list of columns in the dataset, revealing a mix of customer demographics, service details, and billing info. The sample data from the first row helps us see the kind of values each column holds, such as categorical labels like female for gender and numeric values like 29.85 for monthly charges. This initial exploration is crucial for understanding what data we have before performing any sentiment or churn analysis. Practice: which columns look useful for text analysis or predicting sentiment? Step 2. Data cleaning and pre-processing. Text data can be messy. Let us select a simple text field to work with. For this demo, we will create our own simple feedback column as an example. If your dataset has a real review or comment text column, use that instead. Running the cell now. Let us make sure we have feedback to work with for this demo. We add a comment about what we are doing in this cell. We import numpy so we can manipulate lists if we want later. We create a list of short feedback messages, some are positive and some negative. Each entry will look like a short customer comment about their experience. This is another example of a customer sharing something that was not good. This is a positive, complimentary message. This sentence is negative and signals frustration. Here is a comment with a positive feeling. Here is a complaint about the speed of support. This customer sounds very satisfied. This is a negative review saying they would not tell others to use the service. We trim the dataset to only 10 rows so our example is quick and readable. We add the feedback column to the data, using our sample comments. We print both customer ID and the new feedback column. Running the cell now. Here, we've created a new feedback column with sample customer comments to simulate real text data. Notice the column shape matches our 10 sample records, giving us a focused view to practice cleaning and pre-processing text. This step is crucial to prepare meaningful feedback data for later analysis or modeling. Try it. What positive and negative words do you notice in the feedback column? Step 3. Exploratory data analysis for text. Let us explore our new text data. We want to look for common words in customer feedback. A word cloud is a great way to see which words pop up most often. Running the cell now. Let us see which words are most common in customer comments. Our comment shows what we will do in this cell. We import the word cloud library to make a word cloud picture. We import matplotlib for drawing images. We put all feedback together in one string for easy analysis. We create a word cloud that shows bigger words when they are more common. We set the size of our image. We show the word cloud as a colorful image. We remove axis marks to keep the focus on the words. We add a title to explain what is in this plot. We display the result so you can see it right away. Running the cell now. This word cloud visualization highlights the most frequent words found in the customer feedback, with larger words indicating higher occurrence. Notice how this quick visual summary helps us identify key themes or concerns from the text data, aligning perfectly with our goal to explore common words before deeper analysis. Practice. Which words seem to pop out? What do they tell you about customer experiences? Step 4. Association rule mining, brief demo. Association rules show which items or words often appear together. Let us see if there are pairs of words often found in the same feedback. We will use a simple count, not a real association algorithm, to keep it beginner-friendly. Running the cell now. Now let us find out which words are next to each other most often in feedback. We add a comment about looking for popular word pairs. We import counter to quickly count things. We import re so we can split text into words safely. We start with an empty list to collect word pairs. We loop over every feedback message one by one. We turn the text into words, all lowercase so a great and great count together. We look at every pair of words right next to each other. We grab the pair and add it to the list. We count each word pair to see which happens the most. We print the 5 most common pairs. Running the cell now. The output shows the top 5 most common consecutive word pairs found across all feedback entries, with counts next to each pair. Notice that with there appears twice, indicating it's a frequent phrase, while the other pairs appear only once. This simple counting helps identify common word combinations, demonstrating a basic approach to association rule mining by finding words that often appear together. Try it. Do you spot pairs that reveal a strong opinion or pattern? Step 5. Preparing for sentiment classification. Sentiment classification lets us decide if feedback is positive or negative. First, we will add simple sentiment labels to our demo data. We are doing this manually for simplicity, but real projects use label data. Running the cell now. Let us label comments as positive or negative so we can build a model quickly. We explain that a label of 1 means positive, and 0 means negative. We create a list of positive and negative labels to match our feedback samples. We add this list as a new column in our data. We print feedback messages alongside their new numbers for sentiment. Running the cell now. Here, we've added a new column, sentiment, assigning a label of 1 for positive feedback and 0 for negative. Notice that the sentiment labels align clearly with the tone of each comment, setting up our data for the next step, training a model to recognize these patterns automatically. This manual labeling is a simple but crucial step toward building a sentiment classifier. Practice. Can you guess which feedback lines will have a sentiment of 0? Now let us get our data ready for building and checking a model. We add a comment about what we are doing. We import a function to split data for training and testing. X is our input data, which is the feedback text. Y is our target output, which is if the sentiment is positive or negative. We split our data into train and test sets for learning and checking accuracy. We print the number of examples we will use to teach the model. We print the number we use to check how well the model does. Running the cell now. Here, the code splits our labeled feedback into training and test sets, with 7 samples for training and 3 for testing. Notice the 70/30th split, which ensures we have enough data to train our sentiment classifier and a separate set to evaluate its performance. This step sets up a fair test of how well our model can predict sentiment on unseen feedback. You will often split data so you do not test on the same messages you train your model on. Step 6. Building a simple classification model. We will use a naive Bayes model, a simple yet effective way to start with text classification. This model quickly guesses if a message is positive or negative. Let us vectorize our feedback text and train the model. Running the cell now. Let us convert our text to numbers and train the sentiment classifier. We start by writing a comment explaining the steps. We import Count Vectorizer. This tool changes text into numbers for the model. We also import Multinomial NB, a kind of naive Bayes model for text. We make a new vectorizer object to transform text into count data. We fit and convert our training text data into number features. We transform our test feedback using the same tool. We create the model which will classify messages. We train our model using the vectorized training text and correct labels. We print a message showing that the training is done. Running the cell now. This output confirms that the naive Bayes model has successfully learned from the vectorized training data. Notice how we transform text into numerical features with Count Vectorizer before training, enabling the model to handle text classification. This step is crucial for building a simple sentiment predictor that can classify new messages as positive or negative. Practice. Try changing a feedback message and see how the model responds after retraining. Let us see how well our model can spot positive or negative comments on new data. We write a comment about predicting and scoring our sentiment analysis. We import tools to score accuracy and show a detailed report. We predict the sentiment for each test feedback message. We measure what fraction of test messages the model got right. We print the test accuracy so we see how good the model is. We print a more detailed summary to check how it performs by class. Running the cell now. The model achieved a low accuracy of 33%, correctly predicting only 1 out of 3 test examples. Notice the precision and recall for class A1 are 0, indicating it failed to identify any positive instances. This highlights that with such a small data set and basic features, the naive Bayes model still needs improvement, reinforcing the lesson's intent to build a simple baseline before refining the approach. Challenge: try to edit the feedback text and rerun accuracy. Does it change? Step 7. Clustering comments, unsupervised mini-demo. Not all text must be labeled. Clustering helps us group similar feedback without knowing the real sentiment yet. Let us cluster our feedback messages with k-means and see what we find. Running the cell now. Here is a quick way to see which comments might cluster together based on word usage. We add a comment about what happens in the cell. We import a simple clustering tool called k-means. We create a k-means object to split messages into two groups. We fit the clustering using the transformed feedback column. We go through each message and its group assignment. We print out which feedback went into which cluster. Running the cell now. Here we see k-means clustering the feedback into two groups, based only on text similarity without sentiment labels. Cluster 0 contains mostly positive or mixed comments, while Cluster 1 groups the clearly negative feedback, like the single will not recommend message. This demonstrates how clustering helps explore patterns in text data before any formal labeling. Try it. Do the clusters look like positive and negative groupings? Step 8. Trying ensemble voting for sentiment. Sometimes using multiple models at once gives better results. This is called an ensemble. Let us combine our naive Bayes and a simple logistic regression for sentiment using voting. Running the cell now. Let us see how using two different models in a team can improve sentiment predictions. We begin by showing what the cell is for. We import logistic regression to use as a second model. We import a tool to let us combine models into a voting group. We create a logistic regression model for classification. We build an ensemble using the team of models together. The first member is our naive Bayes classifier. The second member in the team is our logistic regression. We tell the ensemble to use hard voting, meaning it picks the most common prediction. We fit the ensemble on training data to learn sentiment patterns. We use our ensemble to predict the test data sentiment. We print how accurate the ensemble is compared to individual models. Running the cell now. The output shows a voting ensemble accuracy of about 33%, which is quite low and even worse than expected. This suggests that simply combining the naive Bayes and logistic regression models without tuning or improving their individual performance may not boost accuracy right away. The key takeaway here is that while ensembles can help, their success depends on the strength and diversity of the models combined. Practice: which did better, naive Bayes or the voting team? Try different test sets. Step 9. Spotting anomalies in text feedback. Sometimes comments are very different from usual feedback. Let us try a basic anomaly detection to see if we can spot unusual messages. This is useful for identifying spam or rare complaints. Running the cell now. Let us try to find out if any feedback looks very different from the rest. Our comment tells us the cell is for simple anomaly detection. We import a one-class SVM, which helps find what is outside the norm. We fit the anomaly detector only on regular training feedback. We get a matrix of our full feedback to score for anomalies. We predict which feedback might be different or unusual. We go through each feedback and check if it is marked as odd. We print the message if it gets flagged as an anomaly. Running the cell now. This output highlights two feedback comments flagged as unusual by the one-class SVM anomaly detector, which is trained on typical feedback patterns. Notice these anomalies express stronger negative sentiments compared to common messages, helping us identify rare or concerning complaints quickly. This basic detection step is key for spotting spam or critical feedback that stands out from the norm. Try it. Does the method flag anything that seems surprising or rare? Step 10. Wrap up and practice. You just covered loading data, cleaning, vectorizing, exploring, classifying, and clustering text. Try applying these skills to a longer column of real customer comments. Practice, add more feedback phrases and improve your model's accuracy. Running the cell now. Remember to like and subscribe to the channel for more hands-on data mining tutorials. Recap: key takeaways. Text mining helps us turn raw feedback into insights. Sentiment analysis finds the mood in messages. Models like naive Bayes and ensembles make accurate predictions. Exploratory analysis gives ideas for improving service. These skills are useful for any industry working with lots of comments or reviews. Keep practicing, and you will be ready for more advanced text mining soon. Running the cell now. Next steps and challenge. Challenge yourself, try using a real dataset with hundreds of text entries. Can your model beat 80% accuracy on new comments? Share your results and thoughts in the comments. Thanks for following along, and see you in the next lesson. Running the cell now. Subscribe for more lessons and let us know what text mining topics you want to learn next.